So in today's video, we will be talking about server rendering and rendering on web. In the previous video, we saw in short how we are going to render our applications on the web. As a developer, we are often faced with decisions that will affect the entire architecture of our application. One of the core decisions web developers must make is where to implement logic and rendering in their application. This can be a difficult since there are a number of different ways to build a website. In order to better understand the architectures, we need to make decisions and we need to have a solid understanding of each approach and consistent terminology to use when speaking about them. The differences between these approaches help illustrate the trade offs to rendering on the web through the lens of performance. So, rendering can be basically of a few types like server side rendering, client side rendering, rehydration, and pre rendering. In today's video, we will be talking about server side rendering in detail. We will also be going through the performance on a basis of time. That is, there are 4 parameters on which we will be seeing them: time to first byte, first paint, first contentful paint, and time to interactive. We will be talking about them in a few minutes. So coming to our main topic is server rendering or server side rendering. Server rendering is rendering a client side or a universal app to the HTML on the server. Rendering on the server is a bit different since it is stateless. Server rendering generates the full HTML for a page on the server in response to navigation. This avoids additional round trips for data fetching and templating on the client, since it's handled before the browser gets a response. The basic idea is that we wrap the app in a stateless, static router instead of a browser router. We pass in the requested URL from the server so the routes can match and the context props that we will discuss. So earlier, when we were doing the client side rendering, then we used browser router to wrap our app component, but in the server, we will be using static router. Here we will have two arguments. First is location and the second is context. When you render a redirect on the client, the browser history changes state and we get a new screen. In a static server environment, we cannot change the app state. Instead, we use the context prop to find out what the result of rendering was. If we find a context.url, then we know the app redirected. This allows us to send a proper redirect from the server. For example, in the next example, here we are creating a const context and a markup which is going to call react dom server and render to string. Inside this, we are passing our static router, the location with the requested URL and the context. So if the context.url is present, then somewhere a redirect was rendered. So this will be redirected to the server 301 to the context.url, or else we are good to send the response. Server rendering generally produces a first paint and a first contentful paint. Running page logic and rendering on the server makes it possible to avoid sending lots of JavaScript to the client, which helps a fast time to interactive. This makes sense since with server rendering, you are just sending text and links to the user's browser. For example, this approach can work well for a large spectrum of device and network conditions and open up interesting browser optimizations like streaming document parsing. So here we are not sending a lot of JavaScript to the client. We are just sending some text and some links. With server rendering, users are unlikely to be left waiting for the CPU-bound JavaScript to process before they can use the site. Even when third-party JavaScript cannot be avoided, using server rendering to reduce our first-party JavaScript cost can give us a more budget for the rest. However, this is one primary drawback to this approach. Generating pages on the server takes time. So this results in slow process. Whether server rendering is enough for the application largely depends on what type of experience you are building. There is a long-standing debate over the correct applications of server rendering versus client-side rendering, but it is important to remember that you can opt to use server rendering for some pages and not others. Some sites have adopted hybrid rendering techniques with success. Netflix server renders its relatively static landing pages while prefetching the JavaScript for interaction heavy pages, giving these heavier client rendered pages a better chance for quick loading. Many modern frameworks, libraries, and architectures make it possible to render the same application on both the client and the server. These techniques can be used for server rendering. However, it is important to note that architectures where rendering happens both on the server and on the client are their own class of solution with very different performance characteristics and trade-offs. React users can use render to string, as in the last example it is used, or solution build atop it like next.js For server rendering, Vue users can look at Vue's server rendering guide or NUXT, and Angular has universal. Most popular solutions employ some form of hydration, though, so be aware of the approach in using before selecting a tool. Adding app-specific context information. The router only ever adds context.url, but you may want some redirects to be 301 and others 302. Or maybe you would like to send a 404 response if some specific branch of UI is rendered, or a 401 if they are not authorized. The context prop is yours, so you can mutate it. So let us see a way to distinguish between 301 and 302 redirects. So we will be adding a function redirect with status. And here we will be having from to status. Now we will be adding root and render, which is assigned to static context there is no static context on the client, so we need to guard against that here. So if static context is present, so static context dot status is set to status, and we are going to return a redirect from and then to. So we will be having some place, like if I am on the home page and I want to redirect myself from the home page to the about page, so I will change that from and to. And inside our main app we will have a switch statement and a redirect with status. So inside my return I will be having a switch. I also need to export it import it at the top. So inside this switch I will be having a redirect with status, the function which I have written, and the status will be set to 301. From my URL is suppose users to profiles. And also if I want to have another redirect, so I will be adding the same statement with some changes. So here the status will be 302 from say courses to dashboard. So as we saw that on the server again there will be a context, and then the context URL will be checked and it will be redirect from context status to context URL. If we have a 404 or 401 or any other status, then we can do the same thing as we have done right now. We will create a component that adds, we can create a component that adds some context and render it anywhere in the app to get a different status. Next, we will talk about data loading. There are so many different approaches to this, and there is no clear yet best practice. So, we seek to be composable with any approach and not prescribe or lean towards one or the other. So, we are confident that the router can fit inside the constraints in our application. So the primary constraint is that we want to load the data before we render. React Router exports the math patch static function that it uses internally to match locations to routes. You can use this function on the server to help determine what your data dependencies will be before rendering. The gist of this approach relies on a static route config used to both render your routes and match against before rendering to determine the data dependency. For example, this is the syntax. So we'll create const routes, adding a path. Let us add the default path, adding the component, say route, and then load data, which is going to call get some data. So we can add functions like this. The basic idea of data loading is to do it like this. And then we will map the routes according to map function. And finally, the client will need to pick up the data. Again, We are not in the business of prescribing a data loading pattern for the app, but these are the touch points that you will need to implement. We will also be talking about static rendering. So static rendering happens at build time and offers a fast time to interactive, assuming the amount of client-side JavaScript is limited. Unlike server rendering, it also manages to achieve a consistently faster time since the HTML for the page doesn't have to be generated on the fly. Generally, static rendering means producing a separate HTML file for each URL ahead of time, with HTML responses being generated in advance. Static rendering can be deployed to multiple CDNs to take advantage of edge caching. Solutions for static rendering come in all shapes and sizes. There are tools that are designed to make developers feel like their application is being rendered dynamically rather than generated as a build step. One of the downsides of static rendering is that individual HTML file must be generated for every possible URL. This can be challenging and even infeasible when you cannot predict what those URLs will be ahead of time or for site with a number of unique pages. So it is important to talk about static rendering a little bit. So I introduced this topic to you, but we will not be dealing with all this right now as this is a vast topic. So we'll just see few differences between server rendering and static rendering. So server rendering is not a silver bullet. It is dynamic in nature and can come with significant compute overhead costs. Many server rendering solutions Many server rendering solutions don't flush early and they delay and double the data being sent. That is inline state used by JavaScript on the client. In React, render to string can be slow as it is synchronous and single threaded. Talking about server rendering produces HTML on demand for each URL but can be slower than server static rendered content. If you can put in the additional legwork, then server rendering plus HTML caching can be massively reduced. It will reduce the server render time. So this is a detailed topic where you will have to understand rendering, but in basic, server rendering is all about wrapping our component inside static router and then searching for the context URL. This is what we will be doing simply right now in the next few examples in the upcoming videos. So that is it for today, and I hope that now you're clear with some concepts of static of server rendering. Not completely, you will start getting it right now. So even some basic concept will be good to go. So that's it for today. I'll see you in the next video. Do like our video and subscribe to our channel. So that's it for today. I'll see you in the next video.